Okay, part 2, second half of exponent rules. This will be the end of this section of exponent rules when we get through this. So here's what we need to know today. The power of a power, and you probably saw this last night. Okay.
Multiply?
Yes. Yep. This is where we multiply. So this is where, bless you, what it sounds like. You have a power taken to another power, right? So basically 2 sets of exponents. So what this says is if a power is raised to another power, you multiply the exponents. If a power is raised to another power, you multiply the exponents. If we're multiplying and the bases are the same, we add the exponents. But if we're taking a power to a power, we multiply. So something like this. We have a power, right? We would call that a power. We've got a base of 4, an exponent of 6, and that power is raised to another power, right? This looks a little bit different than what we saw yesterday. When you have this situation, we multiply the exponents. So when you have a power taken to another power, multiply the exponents. I don't know why I did 2. Okay, so we would do, our base stays the same. The base stays 4. And now our exponent becomes 6 times 3, which is 18. Okay? So same thing with variables. If we have a variable in our power, so w to the 12th, and we take that whole thing to another power. Good. Our base stays the same, w, and we multiply the exponents. 12 times 5 is 60. So our simplified form is w to the 60th. Okay, it says simplify, and as always, as we talked about yesterday, you always need to write your answer using positive exponents. So make sure that before you finish a problem, all the exponents are positive. Oops. Okay. This is from yesterday. Write the answers using positive exponents. So we're going to leave this as a power. We are multiplying, and our bases are the same. So what should we do with the exponents, Malia? Add. Our base is the same. We're multiplying, so we add the exponents. 2 plus 6 is 8. Okay, so 3 to the 8th, and we'll just leave it as a power. Next. Look at this one. We've got negative 4 to the 2nd over negative 4 to the 7th. Okay, we're dividing, and our bases are the same. So what do we do with the exponents?
Don't you have to
Subtract. Subtract. Top minus bottom. Our base stays the same, and because it was in parentheses initially, it stays in parentheses in our answer. Okay, and then we do our subtraction. 2 minus 7. You can't just subtract in the way that makes it even. You got to subtract the top from the bottom, or the top by the bottom. Negative, 4 to the negative 5th.
That's not okay.
It's not okay.
How come that's not negative 1? No, positive 1 because negative 4 don't do each other.
They have the same base. You don't do anything with
So it's because it's in X. Okay, how are we going to get the negative 5 to be positive? How are we going to get the negative 5 to be positive?
Flip it over that fraction.
Good, so we're going to put a little fraction bar and drop the quantity below. When it crosses the fraction bar, do we change the sign of our base? No, we only change the sign, oh gosh, that is, of the exponent. So negative 4 to the 5th, what goes in our numerator? A 1. All right, what about this one? Here we have power of a power. So we have a power taken to a higher power. What should we be doing with our exponents?
Flip it.
First, we need to multiply. First we need, well, we could flip it first, but I would multiply first. 4 times negative 3 is? Negative 12. And now we need to flip it. Right? So yes, so we will put our fraction bar, drop it beneath the fraction bar. And when we do that, our exponent becomes positive. And in our numerator, we put a placeholder 1.
So you can figure it out. Okay.
If there are coefficients, and a coefficient is the number that comes before a variable. So what are my coefficients here? 2 and 2, right? If there are coefficients, you deal with those separately. They have their own exponent. What's the exponent of 2 of our coefficient? No, what's the exponent of 2? What's the exponent of 2?
1.
Okay, these are separate powers.
So it's 1 times 2 minus.
So we deal with the coefficients on their own. So first thing we would do is 2 times 2. Right?
What? 2 times 2 is 4.
So technically what this is saying, a coefficient, this, for example, 2m squared is really saying, bless you, 2 times m squared. Would you agree? Yeah.
Yes.
Times 2 times m cubed. That's sort of expanded form. So what we're going to do is we're going to multiply our coefficients first. Because commutative property says we can multiply in any order. So let's multiply our coefficients first. 2 times 2 is 4. And now we can deal with our exponent, our powers. We've got the same base. We're multiplying. What should we do with our exponents? We've got the same base. We're multiplying. What should we do with our exponents? M squared times m to the third. In what way?
Add them.
Add.
Wait, how do they have the same base? Is that because both of them go in 6?
Nope. How come they have the same base? Because their base is
2m.
m. Okay.
And then
Example. Okay. Let's do one more example. Okay. Well, not one more. We're in like 100 more examples.
Add the coefficients when you multiply?
No, we don't add. We multiply the coefficients when we multiply.
Put 3 and 2 together?
yeah,
Those aren't coefficients. Those are exponents.
Add the exponents if they have.
4x to the negative third times 4x squared.
I got it.
What should we do first?
Add 4.
4 times 4. You got it. Multiply our coefficients. 4 times 4 is 16. And now we've got our two variables. They're the same base. And we're multiplying. So what should we do with our exponents? Add them. What is negative 3 plus 2? Negative 1.
Wait, quick question. I think I know the answer, but I think I don't. Why wouldn't you make it to the fraction beginning?
Why would I know what?
Because when you're both exponents, she said you didn't have to do that.
First, I see what you're saying. You're asking why don't we drop it right away? Do all your dropping at the end. Yep. Do all of the sort of simplifying first by adding, subtracting, multiplying, and then when you get an answer, then drop what you need to drop or move up what you need to move up. Now, can we leave our answer like this? No, because we have a negative exponent. Now think carefully. What needs to be dropped, Malia?
X to the negative 1.
Good. Only this needs to be dropped below our fraction bar. Why do we not drop 16?
Because it's positive.
Because what's positive?
The base of the base.
What is the exponent on 16?
1.
Correct.
So that's positive.
So this has technically an exponent of 1.
But
Yes.
Let's say you had a negative, but it was like 4x to the 4th power, so you did negative 30 plus 4, and
you got positive 1, would you have to flip it then?
No, because then you'd have a positive exponent. Okay, so 16 we are not going to move because it has a positive exponent. What's going to go in my denominator?
To the 1.
Yeah, x to the 1, or just x. Okay, good. Let's do another one.
I can't even look at that. So,
Here's a fun time.
That doesn't look very fun.
Can we do this? Yes, we can do this. It's not hard. It is helpful if you just sort of group together the things that go together. So the coefficients, we'll multiply those by one another. Let's do that first. 2 times 2 is
4.
4. All right, so then let's look at our x's because we've got the same base and we're multiplying. So what should we do with those exponents on our x's?
go and just add them.
Add them. Yes. So our base is x. 3 minus 1 is 2. The math itself is not hard. It's just a matter of what you need to do.
So, would it be 4x to the second power 1y?
Okay, so what do we do here?
Wait,
What do we do here?
it would cancel out the 2, 3, so it would be a 0, which makes it a 1.
Very good.
So would it just be 1 or would it be
Okay, so watch what we do. We have the same base. We're multiplying. We add the exponents. Negative 3 plus 3 is 0. So we end up with y to the 0. But any base taken to a 0 power is 1. Do we need to put a 1 here? No.
If it's to the 0 power, isn't it just 0?
No, any number to the 0 power is 1. We're dividing. So what do we do with our exponents?
Oh, then you add a little 1 to it, and then you subtract it.
Remember, this has a 1 on it. And then what do we do with our exponents? Subtract. 3 minus 1 is 2. Simplest form. Done. All right. Let's look at the next one. Remember, when we have our coefficients, we deal with those on their own. Well, what do we do? What does a fraction bar mean?
Divide.
Divide.
You subtract.
What? No. With the coefficients, 18 divided by negative 3. What does that give us?
2. That gives us negative 6.
Right.
How do you know?
First, we deal with the coefficients. That's basic. 18 over negative 3.
What if it's like 16 C with the negative 3?
Then you can't simplify it. You just leave the 16 on the top and the negative 3 on the bottom. All right. Now we look at our exponents. We're dividing. We have the same base. So what should we do with our exponents? We should subtract. 3 minus 2 is 1. So we can say c to the 1, but we can also just say c. Okay, we don't need to put a little 1. Let's do another one. Okay, let's try this one. Okay, here we've got 3 different situations. First, we've got our coefficients. Let's start with that. Negative 48 divided by negative 8 is what? 6. And that always goes on the top when we do that division. Negative 48 divided by negative 8 simplifies to 6. Okay, now let's look at the c's. We're dividing. What should we do with our exponents? 2 minus 1, which is 1. Or just c. Just c. No, you're right. 2 minus 1. Remember, there's a little 1 on that guy. Okay, and then finally, the d's. Good. D to the 4 minus, don't forget the little imaginary 1,
3.
to the 3rd. That's our simplest form. All right. Next one's easy. Power of a power. We do what with the exponents? Multiply. Good. X to the 14th. Okay, I'm going to do these pretty rapid fire. I want you to do them in your notes. The more practice, the better. And I just want to make sure we've seen all of the different possibilities. X, what do you notice first in this one? 6x to the 5th? X to the 0. What should we do with that term?
1.
It's just a 1. I would just get rid of it. Because multiplying anything by 1 does nothing to change it. Okay, so now we're just dealing with 6 times 3 is 18. And then x to the 5th times x to the 5th. We're multiplying. The bases are the same. So what do we do with our exponents? Add them. X to the 10th. Okay, we haven't seen this yet, so I want to make sure.
I know how to do this. Oh, this is
This is power of a power. Make sure that you give that exponent to both of the terms that are, or not the terms, both of the parts of the expression. So you need to give the 5 to the coefficient, 2 to the 5th.
And is this the one where you add?
This is where we multiply because we're taking a power, a base, with a power to another power. So we multiply. So 2 to the 5th, because it still has to stay as an exponent, right? That 2 has an imaginary 1. So we multiply 1 times 5. 2 to the 5th, x to the 20th. 5 times 4. You can leave it like this only because 2 to the 5th.
You could
2 times 2 is 4 times 2 is 32. I guess we could do it like this. 2 to the 5th is 32.
Oh, because you actually do 2 times 2 times 2.
Oh.
Yes.
And on a test, we leave it 2 to the 5th.
Yes, that would be fine. If it's that big. All right. Let's do these ones and then we'll be done and I'll let you start on your homework. Okay. Okay. Let's start with the x's. Subtraction. Gentlemen.
Just looking at Max's answer.
All right. What do we get when we simplify the x's?
A simplified x.
It's going to be x to the 1 minus x to the negative 3.
Good.
X to the negative 2.
Good. Negative 2. And we'll wait till the end to move everything above and below where it needs to go. And y to the third. 7 minus 4. Okay, there is an issue here. We can't leave it like this. What should it be? Good. What drops?
X to the negative second.
Good. This one goes underneath the fraction bar. The y to the third is fine. It has a positive exponent. We're not going to touch it. It stays in our numerator. And then we drop x to the negative second down so that it gets a positive exponent. Okay, last one. Make sure that we give this to every product or factor inside of our. Okay, 2 to the second times x to the what? Fourth times y to the sixth. Okay, and then let's simplify 2 squared because when we don't leave our numbers with an exponent if it has other variables. So 4 x to the 4th, y to the 6th. Good?
Yeah.
Okay.
So you
Wait,
just leave
keep
it like
that up,
that?
keep that up.